is put. So you have some charge over here. So what would be the force that this charge experiences? Yes. What's the force that this charge would experience in the presence of this electric field? QE, right? So would this force would be F, which is Q. Good. Okay. So now let us calculate the force between the capacitors, between the parallel plate capacitor. So let's say that we have this parallel plate capacitor, and this is the positive one. Okay, and this is the negative one. So this has charge plus Q, and this has charge minus Q, right? So this minus Q minus the total charge is minus Q. So what is the force experienced by this minus Q, right, due to this plus Q charge or this positive plate? So positive plate. Or let me write it as only F minus Q. Okay. So now we are calculating the charge or the force on this plate. So we forget about the electric field and all the other things of this plate, right? So what would be the electric field due to this positive charge of this positive plate? What would be the electric field? So we have this sheet, positive sheet, and we are calculating the electric field at this point. So what would be that, guys?
So like F by Q.
F by Q. Do we know we want to calculate this F?
Oh yeah.
So if I write sigma by 2 epsilon naught, then you guys will say, oh, see. So this is the electric field due to a sheet, right?
Yes, sir.
So electric field due to in this direction also. So we have the electric field, which is sigma by 2 epsilon, right? Okay. So keeping that in mind, so the electric field due to this positive plate is in this direction, and that is sigma, or let me write it as E plus Q. This is sigma by 2 epsilon, right? So force on minus Q would be minus Q into electric field due to Q charge. Am I correct? Yes.
Yes, sir.
So
Yes.
this is minus Q and then E by 2 epsilon, sigma by 2 epsilon naught, right? So this is minus, and what is this sigma? If the area of this plate is A, okay, and the charge is plus Q. So what is sigma?
AQ epsilon 0 epsilon naught.
Sigma. If what is this sigma called? What's the name of this sigma?
Parallel.
Density.
No. Yeah, you
Some-
are. Yeah, Madhya, what are you saying?
Surface density.
Yeah, surface charge density, right, Tariq?
Yeah.
Right.
Yes, sir.
Okay. Shave. Oh, so Shave is there.
Assalamualaikum, sir.
Walaikum salam, sir. So what is this number? 6868637. Okay. So yeah, we just started, Shave. Okay. So now we have completed or we have calculated the capacitance of different capacitor, parallel plate or spherical plate or cylindrical capacitor. Now we are calculating the force between the plates of the parallel plate capacitor. So we have this positive plate and this negative plate. So this has positive charge and this has negative charge, right? So we are calculating the force on this negative charge Q. So that would be this negative charge Q into electric field provided by this positive plate. So electric field provided by this plate is sigma by 2 epsilon naught. And now we were talking about the sigma. So sigma is surface charge density. So surface meaning that we have this area and charge density, which means that we have this Q. So Q by A, right? So this is minus Q and then Q by A and 2E epsilon. So this is minus Q square by 2A epsilon. Is this clear, guys?
The surface charge density formula is sigma is equal to Q by A epsilon naught, right?
By E epsilon naught, why there would be epsilon? So if I write sigma is, or if I write electric field, this is sigma by 2 epsilon, right? For the case
Yes,
of
sir.
the positive state. If we combine positive or negative, then both will give you sigma by inside the plate, you will get sigma by epsilon, right?
Yes, sir.
So, okay, right. So this is only inside the plate, and this is E. This we have derived earlier. Okay, now we have this AE
Sir,
epsilon.
this is force on minus.
Yeah, force on this minus Q charge, right? Force on this minus Q charge. What is the force?
Okay, sir.
Okay, so AEF, so we know that the capacitance of a parallel plate capacitor is AE epsilon naught by T. So we can write AE epsilon naught as CD. So we can modify this further. So F minus Q is minus Q square by 2 AE epsilon naught. Either we can use this, or if capacitance is given. So if capacitance is given, then we can write this as minus Q square by 2 CD. So this is also we can write. Is this part clear, guys?
Yes, sir. Clear.
Okay, so please note it down and then we'll do one question based on. Me, right, this plus. Okay, so that you guys understand that this electric field is due to the plus. So whenever you guys have noted it down, please tell me. Yes. Should I scroll down the screen, guys? Okay, please note down this part. Yeah, someone is saying something. Are you saying something, Madhya?
Then
No, sir. I think I
Okay.
got unmuted by mistake. I wasn't saying.
Oh, okay. Yeah, Chavez? Yeah, are you saying something?
sir finish.
Oh, finished. Okay, so let us do a very simple question, right? And
Sir, on plus charge, how much is the force?
it would be the magnitude would be same, right? Nothing is changing.
Yeah, it's
Yeah, so
only
that would
plus.
be equal to plus q, right? Okay, but this f plus q would be with positive sign. So that is the difference. Okay, so yeah. So the magnitude would be different. Same. So f q magnitude plus would be f minus, and the direction would be opposite.
So direction will be opposite.
Yeah, because you see that if you have this minus q charge, right? So in the electric field, you put a plus q charge. So the force is in this direction. And if you put a minus q charge, so the force is in this direction, right? So for the case of the, so we have this plate, right? And this is positive q, and this is minus. So now we are calculating the force on this plus q charge. So we will neglect the electric field of this one. So what is the electric field due to minus q charge? So this is in this direction. So we have the sheet, right? And this is minus charge. So what is the direction of the electric field? Outgoing or incoming? Yes,
So it's incoming.
incoming, right? So we have this electric field, right? And this is equal to sigma by 2 epsilon naught, right? So we have this electric field minus q, and this is equal to how much? This is sigma by 2 epsilon naught. So this is, right, this is the electric field. Now if we calculate F plus Q, so this is plus Q into electric field minus Q. So we will get Q, and then this is what? Sigma by, and this is 2 epsilon. So this is Q, and then this is Q by A 2 epsilon. So this is what? Q square by 2A epsilon. So you see that we'll get this is positive and that one is negative. So due to this will experience the force in this direction, and minus Q will experience the force in this direction. Right? Understood, Shaved?
Yes, sir.
Okay, so what we were doing. Now let us move on to the next one. Next topic is
And scroll up.
oh, this part you want to note it down. So this is same as the previous one, right? And always remember that the total electric field inside the inside the parallel plate is sigma by epsilon naught due to this plus 1 and negative 1. And outside is 0 and outside is right. So, but when we combine the two
The
elements,
both side is 0.
right? Oh, so you have forgotten that this is negative. So, if we have,
The side it will be 0.
yeah, so where did we use that? Yeah, this one. So we calculated outside this plate, right? And then we found out that this part was cancelling, this part was cancelling. Only the inside part was adding, right? So yeah. Okay, so what we were, where did I? Okay. So the next topic is the energy of the capacitor. Right. So we have this capacitor. This is Q and this is minus. Right. So we know that small work done would be what? In this potential difference V. So the small work done would be, this would be VdQ. Right. And we know that what is V? Potential. This is what? Yes. So C
dq.
is, yeah, CQ. C is Q by V. So V
Part of
is Q by C, right? Who got disconnected? Yeah, so this is Q by C, right, guys? So this is Q by C. Derivation is not important. You guys already know the result. So the total work done would be how much? Integration of Q by C dq from 0 to Q, total charge. So can you guys integrate and tell me what would be, how much you would get? Integrate this and tell me. So integration is Q by C dq from 0 to Q. What will you get? Yeah. What will you get, guys? So let me give you, this is a very trivial question, right? C is constant, so this is outside. And you have this simple integration Q dq from 0 to Q. So now you guys tell me what you will get. You have done a complex kind of integral. This is a simple one, x dx.
So will it be 1 by C into Q square by 2?
Yeah, q square by 2, right? So integration of x, that is what? X square by 2, right? So this is q square by 2 in the limit q and z, right? So this would be how much? 1 by c, and then we put the upper limit, which is q square, and then lower limit 0 square. This would be q square by 2c. This is what you get, right? The T is outside. So this is the energy. Whatever the work done, that will change to energy. This is the energy. Q square by. So this is the energy of the capacitor, right? And this is equal to, so we can also write this as half CV square, or we can write this as Q. So anything that we can write. Oh, one minute. So this is, okay, so Q is CV, right? And, or I can write C as Q by C. So this would be half Q, right? Okay, so is this clear, guys? Yes.
Yes, sir.
So please note it down. This you have already done in your CBSE. So I'm just repeating that. Please note it down. So in the second chapter, you have lots of formula to remember. So you guys have to make a short note of formula and then write it down, and then you have to just remember it. Okay, whenever you guys want me to scroll down this much we can scroll, right? So whenever you guys have
Sir,
completed,
can you scroll up?
oh, I should scroll up this part.
Yes, sir.
Okay, so noted everyone.
So 1 minute.
Yes, noted everyone.
So 1 minute, sir.
Okay.
Yes, sir.
So now the next topic is, this you have already done, but energy density of energy density of parallel plate capacity. And remember, this is a volumetric. So we have this parallel plate, right? This is a sheet. And the distance between them is d, right? So now we are calculating the energy density in this volume, right? So you guys tell me what is density. If I ask you that what is charge density in this volume, so what would be that? Inside this volume, what would be the charge density?
0.
No, no. So I'm not. Yeah, I'm asking that. Yeah, charge is zero, but how do we define the charge density?
Q by 6 epsilon naught this one.
Q by V. Density meaning volume. How? Okay, so let me
Oh,
change.
okay,
So
okay.
if I ask you that what is mass density, right? If I say mass density, so then what would be mass density? Yeah. If I ask you what is mass density, then what is that?
That would be Q by
I have
6
mass,
epsilon.
mass. Why you are why you are sticking to that six and silent? So I'm not talking about flux. Forget about that
Oh,
flux, right?
oh yeah,
So
sorry.
yeah, I am asking mass. So whenever I say mass density, so mass would be in the numerator. Density meaning that volume would be in the denominator, right? So if I
Okay,
say charge density, so charge would be in the numerator, density meaning volume in the denominator, right? So if I
yes,
say energy density, right? So if I say energy density, let's say this is small u. So what would be that? Energy and then by volume, right?
yes,
Okay. So now U is what? This is the energy density, and this would be energy, which is U by volume, right? And the distance between these plates is D, and the surface area of this plate is A. So can you guys tell me what would be the volume? Yes.
So can you repeat?
So the distance between the plate is D. Okay. And the area of this plate is A. So what would be the volume of this? What is what is this cuboid?
AD,
Which
sir.
is 80, right? Good. So that would be 80. This is 80. And energy we have calculated. So that is half CV square. Right, everyone? Am I correct?
Yes.
yes.
Okay. So now we have to write this capacitance. What is the capacitance of the parallel plate capacitor? Yes. What is the capacitance of parallel plate capacitor? Yeah,
A
I
epsilon
think
naught by AD.
A epsilon naught. So A epsilon naught by T. Good. And then what is potential in terms of electric field and distance? What is the potential? Yes. What is the potential? So we have this distance between the plate D and the potential difference is V and electric field is E. So what is the relation between electric field, distance and potential? So someone is talking, but I cannot get. So yeah, what is the potential? When we were calculating the uh, parallel plate capacitor capacitance, so we extensively did this problem. Okay, you guys already know. This we already know, right? So E dot dr and this integrate to E and D, right? So for the parallel plate capacitor, this is the potential, right? Potential difference. Okay, so this is ED. So let us plug in that value also. So this is ED whole square. So A and A cancel, and we have epsilon naught E square and then D square divided by 2 and then D square. So D square cancels, and we have half epsilon naught E square. So this is the energy density of a parallel plate capacitor. Is this part clear, everyone? Is this part clear?
Yes.
Okay, so then you guys please write it down. So whenever you guys want me to scroll down the screen, guys, yeah, whenever you guys want me to scroll down the screen, guys, please.
So can you scroll down? Then
Then, Tarif and Madhya, what about you guys?
Yes, sir.
Okay, so now this part is very important, right? So this part you guys have to remember. So what do we have? We have three cases, right? So let's say in two cases, battery is connected, right? So whenever, always remember that let's say we have this capacitor and some battery is connected. So whenever battery is connected, then the voltage would be constant, right? So this will keep the voltage constant throughout this circuit whenever the battery is applied, battery is connected. Okay, so keeping this in mind, let us do this, or let us,
Sir, can you repeat?
yeah. So whenever battery is connected, right? Whenever battery is connected, so that will keep the voltage constant in this circuit. Okay,
There is capacitor also.
yeah, in the capacitor also. So this, whatever the voltage is there, so this would be equal to this. Okay, so this capacitor, this voltage will provide the voltage. Okay,
Yes, sir.
okay. So now let us understand. So first case is that, so no dielectric, no dielectric between the capacitor and battery is connected. Right. So this is case first. Okay, we have this capacitor and this battery is connected. So this has some charge Q, this has voltage, and then this has electric field, and then this has voltage V. So first thing is that what would be the capacitor? The air is between the plate, right? So A E epsilon naught by T. Okay, let's say this is C naught. Is this clear, guys?
Yes.
And then potential difference. So potential indifference is what? Let's say it is V naught, which is we are providing. Okay, and then third one is the electric field, or let me say charge. So what would be charge? Charge would be how much? Q is C, right? So this is C naught, and is this clear, everyone? Yes, which is, let us say that this is Q. And then we have the fourth case, which is electric field. So electric field is V by T, which is V naught by D, which is, let's say, E naught. Okay. And then the fifth case, which is energy. So energy is half CV square, which is half C naught V naught square, which is U naught. So these are the initial conditions. Is this clear, everyone?
Yes.
Okay. So I will, now what I do is that,
So can you scroll up?
so I will give some time to note it down. But first let us understand. Okay, Tariq. So first
Yes.
let us understand, and then Okay, so now in the second case, dielectric is placed. Dielectric is placed and battery is connected. So we have this parallel plate capacitor and then battery, but some dielectric is placed, right, with a dielectric constant K. So now we know that this is zero. And now what do we do? What would be C? Yes, guys. What would be C?
A into given.
So A by D, which is, let me write it as K. So this AE epsilon naught is what? This is C naught and then K. So I can say that the capacitance will increase. Is this part clear, everyone? Okay. Now battery is connected. So what would be V? What would be V, guys? V naught. So this is C.
So that is same as cell.
Yes, what do you say, Shavis?
Battery is same as cell.
Yeah, so voltage is same as this, right? Okay. Now the third one. What about charge? So this is CV, right? C is C naught K and V is V naught. So this would be C naught V naught, which is Q naught and K. So this is increased or decreased? Huh?
Increase.
Increased, right? So this is increased. And then we have this fourth one, which is electric field. This is V by D, which is V naught by D, which is E naught. So this is the okay. And the fifth case. Fifth case is energy, which is half CV square. So C has become C naught K and this is V naught square. So half CV naught square, which is U naught and K. So energy is decreased or increased?
Increase.
Increased. Right, good. So we can see that whenever we place a dielectric medium in the circuit which is closed, then all the capacitance and charge and energy will increase. Is this clear, everyone?
Yes.
Okay, so please note it down and then we'll do the third case. So where should I? Yes, whenever you guys want me to scroll down the screen, guys, please tell. Yeah, noted everyone. So should I scroll down?
Sir.
Yeah, whenever you guys have noted it down, please tell. Done. And Madia and Tari, what about you guys?
1 minute.
Come on.
Answer.
Done. So now let us understand about the third case, which is now the battery is disconnected. Okay, so whenever battery is disconnected, so let's say this is switch and this is disconnected. So then what happens is that then your Q is constant, right? Charge remains constant and voltage differs. So this is the idea. Okay. Now the case third is that the dielectric is placed and battery is disconnected. Okay, so in this case, what do we have? Capacitance is A E epsilon naught K by D, which is C naught K, right? So this is increased. What about the voltage? So let me write it first, the charge. So let me write it here so that Q is what? Q naught. So this is same. Now, what is voltage? So Q is CV. So V is what? Q by C, right?
Sir,
So yes,
again, how Q is constant?
yeah, because battery is disconnected, so the whatever charge is here, it will not transfer. So that is why the charge will remain constant, right? This voltage is not supplying any voltage in this circuit. So this is disconnected, which means that this part is not supplying anything, which means that whatever the charge is here, that is contributing to the voltage. Understood, Shavi?
Yes, sir.
So
Charge is
we,
remaining there.
yeah, charge will be there, right? So let's say that this was already charged. Okay, it was already charged, and then the battery is disconnected. So it had some Q charge, right? So it is not uncharged. It was already charged, and then we removed the battery is disconnected. Okay. So now what would be potential? This is Q by C. So this is Q naught by this is what? C naught and K. So this is V naught by K. So which means that this is what? Increased or decreased? This is in the denominator. So this is it decreased, right? Okay, and then we have the fourth one, which is the electric. So this is V by D, which is V naught by D into K. So this is E naught by K. So this is also decreased. And then the fifth one, so U is half CV square, right? So this is half, and C is what? C is C naught K, and then V is what? V naught square and then K square. So K cancels and half C naught V naught square is U naught by K. So this is also decreased. Any question in this part, guys? Any question? Any doubt? Yes. Sorry if you
How
want
it will be a decrease?
uh, energy.
Yes, sir.
I- So you see that this is U naught, whatever the energy was there, it is divided by some dielectric constant K, and it is greater than 1. So let's say initially it was 3. Now it is 3 by 2. So this is 1.5. Initially it was 3, now it is 1.5. So this has decreased, right?
Yeah, right.
So, okay. Yes, any doubt? Anyone?
So, sir, when battery is Q will remain constant.
Yeah, Q will remain constant. If battery is disconnected, so Q will remain constant.
So, like there is no voltage, so no Q will be constant.
Yeah, because voltage is decreased because of the capacitance, right? Due to this capacitance, the voltage is decreased, not because of this charge, right? Due to this capacitance, this voltage is.
Sir, if there is lesser capacity, there will be more voltage.
Yeah, if the capacitance is more, so then it will be decreased, right? What did you say? Did you say? Yeah, did you say if capacitance is more, then this would be decreased more?
No, sir, I asked if capacitance is less, then voltage will be more.
Uh, Capacitance is less than voltage. Less than voltage meaning? So these are two different quantities. So how can we compare this is less than? We
No, sir,
compare with,
if capacity is decreased, then the voltage will be more.
yeah, yeah, of course, of course. So if capacitance is decreased, then voltage would be, yeah. But we can see that whenever we add the capacitance, whenever we add the dielectric, so dielectric always increases the capacitance, right? So to decrease the voltage, we have to remove the dielectric. Okay. To increase the voltage, we have to, or to decrease the capacitance, we have to remove this dielectric. That is how we can decrease the capacitance. But if we add the dielectric, then it will always increase the capacitance because this K is always greater than 1, right? Is this clear?
Yes, sir.
Yeah. So whenever we add the dielectric, it always increases the capacitance because you see that this is epsilon naught K. So it increases by K factor. Yeah, you guys please note it down and then we'll do one problem and then we'll move on to the next one. So the next thing is sharing of capacitors and then we will do the combination of capacitors. So series and parallel, then this chapter will be over. Then start the third chapter. I guess Amna ma'am is doing the sixth chapter, right?
Yes, sir.
Okay, so how much she has completed? After Lenz law or what are you guys studying
After lunch, sir.
after Lenz law? Yeah, so please note it down, guys, and then we'll do the one question and then we'll move on to the next topic. So remember, we are only talking about single capacitor, right? When we add two capacitors and when they are in series, then their charge will be constant, and when they are parallel, then their charge will be different. So this is the case. Whenever you guys have noted it down, please tell. Done. Okay, so now let us do. Oh, Tarif and Madia, what about you guys? Noted.
Yes, sir.
Okay, so
Yes.
now let us do one problem so that we can understand these things. So, parallel plate capacitor is filled with a dielectric material. Its area is, let's say, 100 centimeters square with separation 1 millimeter, and it is holding a charge of 4 millicoulomb. Okay, when connected to a 120-volt supply. Okay, so is the battery connected or disconnected in this question?
It's connected.
Connected, right? So, and we have this dielectric. So this is the second case. So now the question is that find the dielectric constant. So you guys please do this question and tell me the answer. So Tarif and Chavez and please find the answer and tell. This is a very direct question. Only we have to remember that which case it is and what is given. So let me tell you that.
Sir, I'm doing.
Oh, you are doing.
We should apply C is equal to K into A mu naught by D, right?
Yeah. So C is equal to
K A epsilon naught
yeah.
by D. Then later we find Q is equal to C, right?
Okay, yes, absolutely right. Good. So Q is CB. Yes.
Sir, can you tell how much is micro to the
How much is what? Epsilon naught. Yeah, how much is epsilon naught? Are you asking this one?
There is 8.85 into 10 raised to minus 12.
No, no. So Chavez, are you asking this thing? Yes. Chavez, your voice broke in the middle. What did you ask, Chavez? Okay, you guys please calculate and tell. Yeah. So who got disconnected? So Chavez, maybe it's some internet issue. Yes, are you guys still calculating? Okay, where did Chavez go? He got disconnected.
Will 4 be
Yeah,
4 MCB 4 into 10 raised to minus 6?
-6.
No, so I'm just asking. I didn't fully calculate.
Oh, so I'll
Not the
I'll have
final answer.
I'll have to also calculate, right? So I'll have to.
No, so that's not the final answer. I just want to ask if 4 MC will be 4 into 10 raised to minus 6. Like, can we take as that?
Okay, so let us try to calculate, right? Are you saying that this
Yes, sir.
is the answer that you got?
No, sir, no, sir. I'm asking for the charge.
Oh, charge. Charge is,
Yes, sir.
yeah, 4 microcoulomb, right? Oh,
Yes,
milli.
sir.
So this is milli,
A
not
millicoulomb. So,
milli. So not micro. Micro is this, right? Micro is 10 to
so
the power -6. Milli is
okay.
-3, right?
Yes, I wanted to ask that -3.
Yeah.
Thank you, sir.
So this is okay. So always remember these notation: milli, micro, giga, fermi,
Yes, sir.
angstrom, nano. These are important ones. Yes, Madhya, what did you get?
I got 265.5. And
265.5.
yes, sir.
and no 10 to the power something like that. Okay,
10
so
to the power -6.
minus 6. Okay, so this is what you and what about you, Madhya? What did you get? Yes. What did you get? Yes. So let us check here, right, Shrav? So Q is 4 millicoulomb, right? And then epsilon naught we already do 8.85 minus 12, and then voltage is given 120 volt, and distance is given 1 millimeter, which is 1 into 10 to the power minus 3 meter. And then what else is given? Area is given, which is 100 centimeter square. So 100 centimeter into centimeter, which is what? So 100 into 10 to the power minus 2 meter and 10 to the power minus 2. So this is how much? This part cancels and we have 10 to the power minus 2 meters square, right? So now we have everything and we have to just put the value. So Q is, as you said, A, E, epsilon naught, T, and K, and then B. So then K would be how much? K would be QD divided by A, E, epsilon naught, and B. This is 4 into 10 to the power minus 3. D is how much? D is 10 to the power minus 3. And A is 10 to the power minus 2. And then what? And epsilon is 8.85 minus 12. And V is 120. So then let us write the numbers in one side. Okay, so this is 3. And then what do we have? So this is minus 9. And in the denominator, this is 10, minus 11, and minus 2. So minus 30. Okay, correct, correct, Tarif.
Yes, sir.
So this is 3 5s are 15, and then this is 25, and then 24 and 26. And then this is 10 to the power 4. Okay, 9 plus 13, so 4. So what is 1 divided by 26.5? So you also could have used the calculator. So this is 0.037. 0.0376 into 10 to the power 4, which is what? So 3.76 into 10 to the power. This is clear. Is this?
I did in a different manner.
Yeah, you did not?
So I did it in a different way.
Oh, you did it in different way. What? So what did you do?
So first I took C is equal to K into epsilon naught by T. I calculated C, then I did C Q is equal to CV. Then I got that answer.
But how can you calculate C, because you don't know K,
Oh, okay, sir.
right?
Uh,
K we have
I
to
thought K
calculate.
would be in. Yes, I thought K would be the same value.
No. So K we have to calculate, right? So in this question, find the dielectric constant. We have to find
Yes.
Okay, so please note it down, Madhya. Understood?
Yes.
Okay, you guys have already you guys have already written the question, right?
Yes.
So just do the note down the solution. Okay. Please note it down, and then yeah, in the next class we'll try to finish this part.